Alright. So today's lesson is going to be the foundation for this whole topic. So if you don't understand anything at all, you've got to let me know. I think some of this is revision, but some of it is probably something you haven't seen before, right? But this whole chapter goes under algebra, which means in year 11, if you see these questions, you are supposed to get them right? And they're going to be everywhere in like another question, like off another topic. Say if it's finance, you're supposed to know how to use these methods to solve that question. So it's very, very important that you know thoroughly how to do these concepts. So the first part is index laws. What is an index? So if I have a number 3 to the power of 5, for example, I'll choose a 3 plus 5. So 3 to the power of 5. Which one is the index? 5 is the index, right? So power and index, they pretty much mean the same thing. It's just that in like when we say 2 to the power of 2, and the power is 2, right? But then if you want to say it more academically, it's index. So the index is just the power on the top. This is the index. And what do we call the number on the bottom? The base, right? It's called a base because it is on the bottom. It's the base of the power. Alright, so first one is multiplication. If I have two indices, so the plural for index is indices. It's already in the title. The product of these two things, if given the base is the same number, then we just add the powers up. So if you have, say, 2 to the power of 2 times 2 to the power of 3, what is your final answer going to be? What's the base? 2. It's going to be 2. What is the power going to be? 5. 2 plus 3 is going to be 5. But can I say if I have 2 to the power of 2 times 3 to the power of 3, can I times them together? No. Why not? Because they have different bases, right? So with these, so examples like this, when the bases are not the same, you cannot just use this rule. It doesn't apply. Same as multiplication, you've got to make sure, first step, that the bases are the same number. So if the bases are already the same number and I do the first number divided by the second number, instead of adding the powers together, you just subtract. So if we have 2 to the power of 3 minus 2, divided by 2 to the power of 2, that's going to give you, on the bottom, 2 doesn't change. The base doesn't change. You just do computation on the indices. So it's 3 minus 2 to the power of 1. But can I simplify 2 to the power of 1? It's just 2, right? And as you can see here, it's not just for a normal a to the power of m divided by a to the power of n. It's also for fractions. Why does it apply to fractions as well? They're exactly the same, right? If I have a to the power of m on top of a to the power of n, that means I'm basically doing a to the power of m divided by a to the power of n. So these are the first two things. We're doing a series of these rules today. So first question, it says simplify the following. First one, x to the power of 4 times x to the power of 5. Bra, can you tell me how much it is?
X to the power of 5 plus 4.
Say that again.
X to the power of 5 plus 4.
5 plus 4, very good. So it's x to the power of 5 plus 4. Can I further simplify this? It's going to be x to the power of 9. Right, so that's the first one. Second one, this is different. Why is it different? There are two different bases, right? What you can do is, whenever you simplify these things, collect like terms. So when you have indices, we determine like terms by looking at the base. If the base number is the same, they're like terms. So what should I combine x to the power of 3 with? X to the power of 2. And with y to the power of 4, I can combine it with y, right? But y is just the polynomial by itself. Does it have a power?
Yeah.
It's just to the power of 1. And now I can combine them separately. So x to the power of 3 times x squared, this is x to the power of 5. And then y to the power of 4 times y1, that's y to the power of 5. And then you just have to write them together, right? The reason why you can just combine them is because it's multiply in the middle. It's not plus or minus. So applying the same rule, can you quickly do question C yourself? And I'll get someone to do it for me in a sec. And I'm trying to go very slowly with these things now because I know some of you might not remember any of this. So it's important that we get on the same page first. Five more seconds. All right, Emina, can you tell me what you did for question C? Yeah.
Well, I don't really remember, but I think it's 6m to the power of 9.
Yeah, very good. But how do we do it? Like that's from your memory, as in you just do it automatically like that.
Well, you can multiply the actual whole numbers.
Yep.
And then you just plus
The powers, right? The indices. Very good. So 3 and 2, even though the bases are different, they're just normal numbers. With normal numbers, so if the base is not a polynomial, you can combine the two numbers straight away. So 3 times 2, you get 6 first, times m to the power of 4 plus 5. So it's 6m to 9. Any questions so far? So second one is division. So we did multiplication before, we're doing division now. The only difference is that in multiplication, you're adding the powers. In division, you're subtracting the powers, right? So for the first one, Saja? 10 minus 2. So the base is x, you do 10 minus 2. This will give you x to the power of 8. Second one. This looks more complicated, right? But does anyone remember how we simplify a fraction? Jana?
Oh, for B?
Yeah.
You do 6 divided by 2 and then with 3, but you put it at the top because it has the larger number.
Correct. So whenever, so if the top has the larger power, you keep the number on the top. If the larger number is on the bottom, you keep the number on the bottom.
Can I make a very quick amendment?
Yeah, of course.
Girls, these were due today, the vaccination. So these students, tomorrow, please, you have to hand it in to me. Asia Ahmed, Hawra, Batul, Yamama, Aburad, Maryam, Juri, Sarah, Fatima, Serene, Husna, Maryam, Malaika, Amina. Make sure tomorrow, girls, you have this with you in the morning. Thank you.
Batul, do you know where Aisha is?
Yeah, she's
Oh, okay. Thank you. Okay, I sort of overheard someone say cross multiply. Who said that? When can we use cross multiply to simplify a fraction? When there are two fractions, right? When they're multiplied together. So in this case, we just cancel out common terms on top and bottom, right? So 8 and 12, the highest common factor is 4. So you can do 2 and 3 first. And then 8 to the power of 6 on the top, 8 to the power of 2 on bottom, the power becomes 6 minus 2. So that's to the power of 4. And it's on the top, right? So it's 2a4, b3 and b2. We see we have b left, b to the power of 1, so that's just b. And on the bottom, we don't have anything else. So that's the answer. What I would do is, as I go through these terms, I'll just cancel the powers out. And if the whole term gets cancelled out, I just cross out everything. Yep.
Do you want us to show with me now? Like, can we just put an answer?
Yeah, if you are very confident about how to do this, then yeah, feel free to do it. Alright, question 3. Do you want to quickly try yourselves first? You finished, Emma? Ten more seconds. Shouldn't take longer than that. Our first one, Leila. Can you tell me how to do the first one? Do the divide first. You can? Take a, you have pennies. X to the power of 3. Which part? Oh, the answer is x to the power of 3. How'd you get that? Sorry, I got a bit distracted.
X, so you do 4 minus 3, so x 2 times x.
Is it 4 minus 3 or 3 minus 4?
3 minus 4.
It'll be 3 minus 4. Right? Because x to the power of 3 is in the front. And the only time you really, you can do it that way, you can do the division first, but the only time you actually have to do division first, or not really, is when there's fractions. So if something is divided by a fraction, you need to take care of that division sign first. But other times you can just do everything together, yeah? Especially when there's no fractions. So what you can do is, I think the only part you got incorrect was the order of that. So x to the power of, it's 2 plus 3 minus 4, right? And then you can just put the whole thing into a calculator, but I'm sure this is an easy enough calculation to just do in your head. So this is just x to the power of 1, which is x, right? Second one, Sarah, can you tell me how to do it? Yep. Say that again. Yeah, very good. If you you can do it without multiplying them together, but I think if you times them together first, it will make your calculation a lot easier, right? So can you tell me what goes on the top?
16.
Yeah.
A to the power of 5 and b to the power of 4.
Yeah, very good. On the bottom, it doesn't change. Yes?
Would it be 4AB2? The 4AB2?
I haven't finished yet.
Oh.
Alright, next one. And then I just have to cross out the like terms, right? So can you tell me how to do it, Sarah?
You divide 16 by 4.
Yeah.
By 4.
You get 4.
Yeah, and you minus a to the power of 5 and a to the power of 4.
Yeah, so you minus the powers, right? 5 minus 4, you'll get 1. And it goes on the top. Next one. 4 minus 2. And on the bottom, you don't have anything. So as you can see, in my working out, I've crossed out everything on the bottom. What does that mean? Is it 0 on the bottom?
1.
It's 1 on the bottom, right? So it's 1 on the bottom. And then on the top, you have 4ab squared. So then I can just simplify these to 4ab squared as the answer. So can you put your hand up if you've seen these before and you're 100% confident with these questions? Alright, almost all of you. Can I move on? Yeah? So next part is where instead of writing things separately, so instead of writing them like this, if we just have brackets, so a to the power of n, a to the power of m, brackets to the power of n. What does that mean? I just have to times the powers together, right? I feel like I talked about this at the start of this year. So you need to really differentiate this one with a to the power of m times a to the power of n. Because the answer to this one is going to be a to the power of m plus n, right? But if it's the whole thing to the power of n, it means I'm doing a to the power of m times together for n times, right? Instead of just having two things. So the power will be a lot bigger. And if you have a to the power of 0, this is when it's equal to 1 whatsoever. So it doesn't matter how much the base is equal to, your answer will always be 1. Alright, so example 4, first one, let's just quickly do them together. It's going to be x to the power of 5 times 4, right? So that's x to the power of 20. Second one, does this squared apply to 3? When does it apply to 3? When it's inside the bracket, right? But in this question, it's not. 3 is just outside by itself. So you just do 3 to the power of 3 times y to the power of 5 times 2, 10. And that will be your answer. Now question 5 is sort of combined, right? Can you quickly try it yourselves first? So try example 5. Yeah, the 3 questions yourselves first. Okay. Who needs more time? Does anyone need more time for these questions? Alright, let's have a look. So first one, I'll get Ula to do it, please.
X to the power 6 times x to the power 15.
Yep.
X to the power 21.
So this is equal to x to the power of 21. So you times the powers together, and then you add the powers together, right? Next one, Mariam.
M to the power of 5.
M to the power of 5. Can you tell me step by step how to do it?
M to the power of 12 over M to the power of 7
Yep.
equals M to the power of
So this is equal to m to the power of 5, because you just do 12 minus 7 for the power, right? Next question, Wasila. So what's the first step?
You times the top one,
Yeah, you times the top.
and you get 12x to the power of 5 because you plus the power.
Yeah, very good.
And then on the bottom it's just 6x to the power of 5.
Yeah,
And then you plus x to the power of 5 out for the top and bottom.
you're very good.
And then you get 2.
Yeah, very good. Because it's 12 over 6, right? 12 over 6 is just 2. Hands up if you got all of these 3 correct.
Oh, wait, I'm just
Alright, very good. Alright, moving on to the next part. Moving on to the next part. This is where you have these things to the power of 0. So for the first one, minus 3 to the power of 0, it's just 1. Every time you just need to check, do the brackets apply to every single thing? If it's not, you just take, so 1 is just going to be whatever that's in the bracket and everything else by themselves. And it's minus 5x to the power of 0. What's the answer? Minus 1, right? The reason why it's minus 1 is because the minus sign is outside the brackets. Next one. So 2y to the power of 0 minus 3y to the power of 0. It's going to be 2 minus 1. Any questions here?
Yes.
Yeah, what's your question?
Why is it 2 not 1?
Because, what's the 0 applied to?
After the Y.
It's only to the y. 2 is outside. But in the second one, 3y, this whole thing is inside brackets to the power of 0. So the whole thing becomes 1, right? So 2 minus 1, this is equal to 1. Alright, next part. I know we're going through quite a few things here, but I'm sure a lot of it is something you have already been using in your not day-to-day calculation, but like in everything we've done so far. So it's not like we're teaching completely new concepts. So the next one is pretty much the same as this, the distributive law. If you have two polynomials, so if I say a, b, x, y, and I have to the power of m for the whole thing, but make sure inside it's a times b, not a plus b. It has to be multiplied inside, so it has to be a multiply sign. That's when you apply the power to both things, or if there are 3 terms inside. So if you have, say, x times y times z to the power of 2, what's the answer going to be? So x to the power of 2, so x squared, y squared, z squared, right? No matter how many terms, how many polynomials you have inside your brackets, that's how many times you apply the power to the basis. Same thing happens for division. So with division, if you have a to the power of b, the whole thing to the power of m, then this power applies to both top and bottom. So for example, if you have 2 to the power of 3, the whole thing to the power of 2, then this will become 2 squared on the top over 3 squared on the bottom. So this is 4/9. Yeah, and there's another example given by the question already. Any questions?
Do you have to copy them down?
Do you not have these on your handout? Oh, you mean this?
Your handwriting.
Yeah.
Oh,
Can you copy this as well? So once you finish copying that, can you just do example 7 yourselves? Examples 7 and 8, you can do them together actually. One's division, one's multiplication, that's the only difference. Okay, let's look at example 7 together first, because I'm sure all of you have finished it. First one, when I was looking at a few of your answers, I already saw quite a few different versions. What is it supposed to be? Is it 5 times 3? It's 5 to the power of 3, right? So your answer should be 5 to the power of 3, b cubed. So what's 5 cubed? It's 125. If you're not confident, you can just put the whole thing into the calculator. So 5 cubed is 125 times b cubed. Second one, also, check your answer very, very carefully. What do I do with the minus 2? In brackets, to the power of 4. So essentially, you can think, how many terms do I have in this expression? I have minus 2, I have x cubed, I have y, right? And this to the power 4 has to apply to all 3 of them. So if it applies to all 3 of them, what happens is, you do minus 2 to the power 4. You do x cubed to the power 4. You also do y to the power 4. Right? It has to apply to every single term. And you have 3 terms here. So minus 2 to the power 4. In your calculator, you also have to put the brackets, or else your answer is going to be negative. Negative 2 to the power 4 should be 16. 16 times x to the power of 3 times 4. This is 12. And y to the power 4. So this should be your answer. Hands up if you got this question correct. Alright. About 10 of you. You got it right? Okay. Yeah?
Why isn't it minus 16?
Because minus 2 to the power 4, the whole thing to the power 4.
Okay.
Yeah? Alright. Next question. For this one, does the power of 5 apply to 4? Why not? It's outside of brackets. Right? So if 4 stays the same, it doesn't change. 4 times c squared to the power 5. So that's c to the power 10. And then d cubed to the power 5. That's 3 times 5. D to the power 15. Right? Alright, next one. Question 8. First one, simplified following. The first question 8 is pretty straightforward. Right? It's just 6 cubed over b cubed. So 6 cubed is 216. So 216 on the top over b cubed. Whenever it's a number and you're getting to your final answer, right? Just make sure that you write it as a normal number. Because 6 to the power 3 is not even that big. You can easily write it as 260 on the top. Second one, I guess same question kind of appears here. Because how many terms do you have on the top? You have 2. Minus 2 and a squared. So you need to do minus 2 to the power 4 times a squared to the power 4. On the bottom, how many terms do you have? You have 3 terms. So 3 to the power 4, and you have b to the power 4, and c cubed to the power 4. Don't forget, very, very important, that you're applying the power to every single term. Okay? So on the top, minus 2 to the power 4 is positive 16 times a to the power of 2 times 4, 8. And on the bottom you have 3 to the power 4, that's 81, right? So 81, B4, C12. Is there anything you can cancel out? No. Even though 16 and 81 look like they might have something in common. If you put 16 over 81 into your calculator, you will see that's already simplified completely. Hands up if you got this one correct. Alright, very good. Alright, next point. We were dealing with mostly just positive powers, right? What if the power is negative? What does that mean? If the power is negative, say if you have 2 to the power of negative 1, what does this mean? Does anyone know? Yeah, Batu?
1 over 2 to the power 1.
Yeah, very good. So whenever you see a negative sign, to get rid of it, you write it as a fraction. So whatever that's here goes on the bottom, and it's 2 to the power of negative 1. So 1 is the actual number, right? It goes on the bottom with it. So 1 over 2. What if you have 2 to the power of negative 3? What's that equal to? So once again, you change it into a fraction first, and it's 2 to the power of 3. And that's not 6, it's 8. So it's 1 over 8. 1 over a. So whenever it's a fraction, flip it first. Whatever the power is, that's going to go on the bottom with your actual base.
Can you explain that again?
So negative means fraction, right? If you have 2 to the power of negative 1, 1 is the actual power. Negative just means it's a fraction. So flip it into a fraction. On the bottom, you have 2 to the power of 1. If it's 2 to the power of negative 3, 3 is the actual power. Negative means it's a fraction. So change into a fraction. On the top, it's always 1. Yeah? And then on the bottom, it's 2 to the power of 3. Yeah? Okay. So example 9, first one, x to the power of negative 2. What's the actual power? 2. Right? Negative means it's a fraction. So 1 on the top, x to the power of 2. Second one. What's the only thing that's on the bottom?
No.
A is on the bottom with a power of 2, right? Once again, if the power is a positive whole number, it stays on the top. If it's negative, it just tells you that one term. Whatever the negative power is applied to, that term is on the bottom. So 3 on the top, a negative 2, so that bit becomes a squared. B to the power of 4 is on the top. So all you need to do is flip the a squared, a to the power of negative 2, to put on the top, on the bottom, sorry.
If there's a number, see how this to be, you don't put 1.
You don't what, sorry?
See, you know how this to be?
Yeah.
You have to put 1.
No, you don't. It's only when the power is negative. Because 3 is 2 to the power of 1. 1 is still a positive whole number. Right? Alright, next one. So flip the page. The last one is surds. So with surds, I guess we can sort of summarize. If a power, so if an index is positive and a whole number, then it stays on the top. If an index is negative, so an index is negative, whole number, that means it's a fraction, so it stays on the bottom. If an index is a fraction, then it means this number is a surd. So what is a surd? Whenever you see the square root sign, it means it's a surd, right? So in this case, if you have a to the power of 1 over q, this tells you it is a surd first of all, and whatever that's on the bottom, it's outside the surd, it's on the top. So if you have a to the power of 1 over 2, first of all, the fraction means it's a surd. What stays inside with a? So you have the square, the surd sign. What stays inside with a? 1. Whatever that's on the top, it stays inside. Whatever that's on the bottom, it stays outside. So it's a to the power of 1, which is just a itself. Where does 2 go? Is it 2 times square root of a, or is 2 on the top? 2 is on the top, yeah? So if 2 is on the top, it means it's just a square root. And in this case, we usually don't write the number outside, because that's what we're normally used to. Say square root of 2, square root of 3, we don't have 2 outside, right? But if it's a to the power of, say, 2 over 3, first of all, it's a fraction, so you'll have to write it as a surd. What is outside? 3 is outside. Whatever that's on the bottom is outside, and inside you have a to the power of what? 2. So that's actually, the second rule. If you have P over Q, P stays on the inside, Q stays on the outside. Have you seen this before? I don't think you have, right? Any questions? Huh? Would you say sorry?
Who came up with this? That's the thing.
The reason why it's like this is because sometimes you might have a surd times a normal number, right? If I times these two things, it's easier if they have indices. Because with indices, I know if it's multiply, I plus the powers. If it's divide, I minus the powers. It's a lot easier than if you do them separately. Yeah, it makes a lot more sense. So I would say indices is like a medium of, say, normal numbers and surds. That's the purpose of it. So let's say for the first example, how do I rewrite this as an index? Fifth root of b. So it's b to the power of 1 over 5. That's because, first of all, it's a surd, so I know the power is a fraction, right? Whatever that's inside stays on the top. Whatever that's outside stays on the bottom. So it's 5 on the top, on the bottom, 1 on the top, divided by b to the power of 1 over 5. And then how do I further simplify this? It's just 1. You can either do it by thinking a number divided by itself. A number divided by itself is going to be 1. Or you can use the index log for division. So b to the power of 1/5 minus 1/5. And that's b to the power of 0, which will give you 1 as well. So once you've changed everything into indices, you'll see it's a lot easier to combine the surd number with just a normal number, right? But if you just have whatever you have there, would you know it's equal to 1? Probably not. Can I move on? Yeah? So next one is just numbers. But with these numbers, we have to the power of a fraction. What's the first one going to look like as a surd? So we know it's definitely a surd. Inside we have 32. 32 to the power of what? 1. And outside it's 2. So square root of 36. That's just equal to 6.
So we put the 2 outside?
Yeah, but 2 outside is the same as if I don't write anything. Next one, 8 to the power of 1/3. So square root, inside I have 8 to the power of what? 1. Outside? 3. So it's basically cube root of 8. That's 2. Next one, 27 to the power of 2/3. So inside a surd, you have 27 to the power of 2. Outside you have 3. And you can just put this whole thing into the calculator. 9? Actually, here I can even, I'm not sure if in your homework this will come up, but 27, can I write it as something to the power of something? What's 27 equal to? Can I write 27 as an index? 3 to the power of what? 3 to the power of 3, right? So it's equal to, inside you have 3 to the power of 3 squared. What's this? Now as in, I still want to keep it as an index. 3 to the power of 6. So this is cube root of 3 to the power of 6. Now, can I rewrite it as an index? The whole thing. So it's cube root of 3 to the power of 6. If I want to rewrite it as an index, first of all, what is the base? The base is going to be 3. And the power... You finished? Yeah. Oh, sorry. Why did I take that? And the power is going to be a fraction because it's a third. What's inside? 6. And what's outside? That's 3. So 6 over 3, this is 2, right? So we can further simplify it to 3 squared. And that's equal to 9. Can you copy this down? I know this looks very long. Alright. Sometimes, in later questions, you might need to use this. So just copy this down first. But really, how do you call it? I'm just breaking it down here. That's why there's so many steps, right? But once you're familiar with how to do it, you don't have to write any steps. Does anyone want me to re-explain any part of this? Yes? Here, 3 to the power 3, that's just equal to 27.
What do you get the 3 from?
Because I can only rewrite 27 as 3 to the power 3. Yeah? You can just think, 2 to the power something, can it be 27? Impossible. So go up to 3. 3 to the power 3 is 27. Yeah? Sometimes it takes a few tries. Alright. Can I move on? Actually, for the next question, let's just do 16 to the power of 1/4. Just do positive, change the negative to positive. Because I want you to also try using the method I just did to do it. So don't use the calculator, use the method I just did. Yep, the long one. So try it first. So double check first of all if you have the correct third. It's 4th root of 16. Yeah, then what do you do next? You have 4 squared. The 16 is actually 2 to the power 4. So you can further off because 4 is 2 squared.
Oh yeah.
Yeah, so it's actually 2 to the power 4. Has anyone got it? If you've got it, can you just show me your answer? Very close. If you have already gone to your point, yes? The power 3? That's just something you need to know. 3 cubed is 27. Yeah? Very close. If you get 4 to the power 2 over 4, you're very, very close. Yeah, that's correct. So you got it right. Yeah, correct. Or also got it right. Yep. Also your mama got it right. Very close. Yep, correct. 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 Okay. So let's have a look. I'll do my method first, yeah? 16 is equal to what to the power of what? So 4 to the power of 2. First of all, let's just actually use this one first because I think a lot of you have this one. Okay. If you have 4 to the power of 2 already, and I want to rewrite it as an index, this will become 4 to the power of 1 over 2. Right? Because 2 over 4 is 1 over 2. But this is basically, so 4 to the power of 1 over 2 is equal to square root of 4. What's square root of 4? That's 2. So if you give 4 to the power of 1 over 2, you're very, very close. Because 4 to the power of 1 over 2, you can further simplify it. Right? However, this is not the method I used. I didn't choose 4 as the base. So 16 is also equal to 2 to the power of 4. If you did it like this at the start, your answer will be a lot easier, right? So this is equal to 2 to the power of 4 over 4, which is just 2 to the power of 1. So that's equal to 2.
Is it right, both of them?
No. As long as you get a correct answer. Yep.
You know, to the third method, I'm confused how you got the perimeter of
How I got
1 over 2.
1 over 2? Because it's 2 over 4. Right? Alright. I heard some of you say I can just easily use the calculator to do it. However, in some questions you need to derive it yourself. You can't just use the calculator. Yes?
For the last part, can you just use the calculator?
Yeah. Once you have 2 to the power of 4 over 4, you can put it into calculator. Yeah? Alright. Next one. Next one, I have a fraction to the power of a fraction. So first, applying the law where it says a over b to the power of m, this should be equal to am over bm. Right? So that means whatever power you have, it has to apply to both of them. So you'll have, first of all, a to the power of a third over 27 to the power of 1/3. Any questions here? So this is equal to, on the top you have cube root of 8, on the bottom you have cube root of 27. Right? I'm just rewriting the indices into certs. Next, what's cube root of 8? That's 2. What is cube root of 27? 3. So you can actually simplify this to just 2 over 3. Yes? Oh yeah, actually, that's a good idea. So Mesa asked, if we have 16 to the power of negative 1 over 4, what's the answer going to be? So you have, what does negative mean as a power? Fraction. So for this fraction, it's 1 over something. 1 over 16 to the power of what? It's 16 to the power of what? 4? We only took care of the negative sign. So it's just 1 over 4 as a power. So it's going to be 1 over, we already saw 16 to the power of 1 over 4 is equal to 2, right? So basically, your answer is just going to be the reciprocal of what you have here. 16 to the power of 1/4 is equal to 2. So your answer is just going to be whatever you have for the positive one flipped. So like I said, I know some of these concepts are what you have learned, but some of it is what you've learned today, right? So today's homework is going to be exercise 16H, the worksheet I gave you, questions 1 to 2. I want you to do every single question properly so that you know exactly how to do them, and tomorrow we'll do the rest of the worksheet, yes?
Miss, so if you get a negative in the exam, you can just work it out as a positive and advance.
Yeah, very good. So Mariam suggested that in the exam, if you see a negative fractional power, you can do the positive one first and then flip it. Yes? Ula? No? So can you start doing your homework, please? There's 2 minutes left.